Hey everyone. So lately I've been thinking a lot about what AI products should actually look like in the real world. And we see so many AI demos and POCs on everywhere on social media, but I wanted to build something different. An actual AI product that solves a real problem, that's something you can use day to day and something that just works without you having to just think about it. Because at the end of the day, that's what AI should actually be doing right in your use cases. So solving some real life problems and making things easier. So I just went ahead and started brainstorming a few notes and also started brainstorming a few of those ideas. I started researching on some use cases and I came back with this one scenario that think about the last time you were driving alone at night, maybe on a highway, and you had that moment of where you actually thought of what if something happens to me right now? You're not gonna call Siri and just say call it 911 or anything like that, right? Because the reality is most emergency systems we have today require you to actually do something. You have to press a button and say the same kind of note that, hey Siri, call 911 or unlock your phone. But here's the thing, in a real emergency, you might not be able to do any of that. And that's when the idea made its way on my weekend project Munchies. So I started thinking, what if we could simply build something that just listens? Something that can automatically detect these distress situations and trigger help without someone needing to do any manual call or simply press anything or even call out Siri. But there was one major problem that I didn't want this to be another cloud based system that is simply constantly uploading your audio to some server, and that creates privacy concerns. So it's also going to add latency and simply fails if there is no connectivity. So the goal was simple now. You have a fully on device, you have privacy first, and you have to take things real time. Now we dive onto the tech stack. That was Qdrant Edge, YAMNet, and SigNoz. The system uses YAMNet, which is a lightweight 3 MB audio model that you might have heard from Google, and it converts live audio into embeddings that basically behave like acoustic fingerprints of sound events. And then we have embeddings. They are searched locally using the Qdrant Edge, which works almost like the SQLite for the vector search, everything running locally. And everything runs directly in process with no external server involved. And the database contains indexed emergency related sounds like screams, crashes, sirens, or even glass breaking. And now the interesting part was also that we required here temporal smoothing. So instead of reacting to one random loud sound and triggering those SOS calls again and again, the system waits for three consistent detections within a 5 second window. And that massively reduces all of those false positives from things like door slamming or even some traffic noise. And because this is running on edge hardware, observability became super important too, because I have to integrate SigNoz to monitor the full pipeline performance and also help me to go ahead and measure things on a production level. For example, issues around latency could be taken care of. YAMNet embeddings took around maybe 23 milliseconds, and then coordinate vector search stayed under 1 millisecond, and the entire detection pipeline consistently ran under 14 milliseconds overall. And that's the kind of observability I was able to get through SigNoz, and which means the system easily stayed within the real-time processing video, which was our three and the third use case that we have to take care of. And importantly, SigNoz only receives metadata and traces, so never the raw audio itself. So the privacy aspect again remained intact. So now, as we have everything sorted out, it was the time to build it. And over a weekend, I built it out and it simply worked. Once the system confirms an emergency, it instantly sends a telegram alert to the emergency contact with the details like detected sound, the severity score, and also similarity match, and also the timestamp that are all within about a second of detection. And I tested it across multiple different scenarios like screams, crashes, sirens, and all of those distress sounds. And also the alerts started come through in real time, which was honestly pretty good to go ahead and etch everything around. And now it's the kind of AI that actually I like to go and build. System that quietly run in the background, activate only when needed, and solving some real use cases. And the entire pipeline, the audio capture, embeddings, vector search, and editing runs fully on device. So no raw audio leaves the system, which keeps it fast and also privacy focused. And the best part is that it's everything open source. So that's why I have it around here. And I have shared the complete architecture, design decisions, and the implementation in a GitHub repository. You can definitely check out. And also, I have written a complete article so that if you want to go ahead and see how my complete walk around was like, the technology I used and why did I use it, you can definitely check that. It's everything in the description, and I would genuinely love to hear your thoughts. See ya.